Here is our basic formula for logistic function. And we're really not going to spend too much time on what everything means. But we have C over 1 plus AE to the negative B X power. What we're focusing on on this formula is that top number. Whatever that top number is, which is represented by this C, that is considered your limiting value or your upper limit. So those two terms mean the exact same thing. So here's kind of your pictures of your graphs of your two logistic models. We could have an increasing function or a decreasing function. So here when it's increasing, it's going to increase very, very slowly. And then all of a sudden it's going to increase very quickly. And then it's going to keep increasing, but it's going to slow down because what we have at that y equals c, which is again that top number, that upper limit or that limiting value, we have a horizontal asymptote. So it's never going to actually reach it, but it's going to get closer and closer to that number. A very realistic and recent event. I don't know what I'm trying to say. This is a struggle, but a very recent event that has happened is COVID. COVID can be represented by a logistic model, right? At first, we heard a couple of cases in California, and then, oh my goodness, a couple in New York, and it's here and it's there. And then all of a sudden, it just took off, right? And everybody started catching it. Your mom had it, your sister had it, your sister's boyfriend had it, your uncle had it, your best friend's brother's dad had it. I don't know, right? But all of a sudden, everybody had it, you had it, and then now it's kind of run out of bodies, right? Now we've had the vaccine. Now we're building up immunity. We're wearing masks, whatever the case is. And now it's going to start slowing down this spread. There's still been a lot of people that have it. There's going to be a few people that haven't had it, but it's going to start slowing down simply because we're building up immunity and there's not enough, you're running out of bodies. Okay, another popular one is about vegetation and deer, right? If you start off with, let's say, 5 deers in a meadow, it's going to go really slowly because there's not a lot of deers to populate. But then all of a sudden, now we have 50 deer and they're all populating with each other. And so now it's just going to grow insanely fast. But then what's going to happen is we go up here, now we're going to have too many deer. And so now we're running out of food, running out of water, and now we're going to kind of start slowing down on that increase. So those are, a couple realistic ways that logistic models represent the world, I guess. So let's go into example 1 now that I am done rambling. Example 1 says graph the function f of x for t equals 0 and t equals 15. So here is my x min, here is my x max, because we have x min and max, but nothing on those y's. We will do zoom 0. Now, when you put these in, you have to make sure you use your n over d or you will get this wrong. So in my calculator, I need to hit alpha y equals for that n over d. We have 1000 and then type in the bottom. And of course, instead of t, we're writing x. Then I'm going to go into my window. We're going 0 to 15 and then zoom 0. Okay, so there is my model. So the first thing we want to do on A and B, find f of 2 and f of 5. So if I already have that graph, the best way is either your table or your trace feature. So I personally kind of like trace. So trace 2 gives me this. So this is about 401.98. And then I've already used trace, so I will just then hit 5 and enter. And that's 909 point, we'll go 0.11. Okay, so again, how did we get those? Because we've already graphed this. So this is trace or table to get these values. And so to use that table here, here's my f of 2, and there's my f of 5. So is this function increasing or decreasing? Well, you can see right here, when I go from 2 to 5, my numbers are increasing. And you can also see it from this graph here that it looks more like this one here. And then what is the limiting value of this function? Your limiting value is this top number here. It's the C. So here, my C equals 1000.